Welcome back for another 7 Caillou challenge called Survive the Attack. This is a cool puzzle because it's kind of like something you might do if you were making a game. Of course, it's overly simplified. That's what we need for a 7 Caillou challenge, but you can kind of see how you might get there. Anyway, given two arrays, notice they're passed as inputs, in which values are the power of each soldier, return true if you survive the attack or false if you perish. It's coming from the perspective of the defenders, and they give you the conditions below. Each soldier gets paired up with its corresponding index in the array, so element 0 is compared to element 0 in defenders, element 1 in attackers is with element 1 in defenders, etc. The survivor is the number with the highest value. If the value is the same, they both perish. If one of the values is empty, which can happen if these arrays are different sizes, the non-empty value soldier survives, which makes sense, right? It's like there's nobody to fight, so they survive. To survive, the defending side must have more survivors than the attacking side, in case there are the same number of survivors in both sides. All right, so what they basically tell you here is that, very simply, more survivors wins, makes sense. But we could have a case where we need a tiebreaker, and that's what this next clause is about. In case there are the same number of survivors in both sides, the winner is the team with the highest initial attack power. If the total attack power of both sides is the same, return true. That's kind of like the tiebreaker goes to the defenders. You get the initial attack power by summing all the values in the array. So then check out these examples. You got two arrays sized the same, so it's just straight up comparison between the two. You can see 1 loses to 2, tick 1 for the survivors of the defenders, 3 loses to 4, 5 loses to 6, 7 loses to 8. So the defense wins all 4 battles, returns true. Now we have an example with different sizes arrays. So the first 2 battles go to the defenders again, but they don't have these extra soldiers that the attackers do, so those 2 win. So you get 2 and 2. Notice that when you sum the attack power, it comes out to 16 for the attackers, and so we return false in favor of the attackers because that tiebreaker went to them. That was this damage, 16 beats 6. And then a final example, it's 4 on 4 again. You can see the defenders win 3 of those battles, so you return true, which means defenders win. So I think that's pretty straightforward. You know what to do. Go ahead and pause the video. Try this one out on your own and come on back when you're ready. And I'll go over my solution, a solution. So the first thing I want to do is address this issue where the arrays passed in are not the same size. So at first, I kind of leaned toward using enumerable, its zip method, where you can kind of combine 2 arrays, and maybe I would take the corresponding elements of each and find the difference between them, you know, and then maybe it might have, the resulting collection might have negatives when the defenders win and positive values when the attackers win, and then I could sort of count those up to figure out who won. But I didn't like how enumerable zip handled the case when the collections were not the same length. And you could certainly accommodate that, but it seemed easier just to sort of go with my own solution here, so that's what I did. So first things first, I want to know how many soldiers I have to process, which would be the length of the longer of these 2 collections, right? When they're not the same size. If they're the same size, it's fine. It's the length of either one. But we got to make sure all arrays are fully processed. So I'll say int size equals math. Math has a max method where you can give it a couple arguments and it will just take the one that's larger. You may have guessed there's a corresponding min if you wanted the lower of 2 values. I'll use max. So attackers.length, we know arrays have a length property, and defenders.length. So now I'll have the length of the longer of the 2. Okay, good. So now when I loop over these, I know how many to do. The second concept I want to introduce here is that I decided to make an integer variable I call balance. And the idea is going to be that I'll sort of increment and decrement this as I process each battle between soldiers, and I'll bump it in the positive direction when the attackers win, and I'll decrement it, meaning go negative when defenders win. With the idea being is that after I process all the battles, I can just check if this value is positive or negative, or possibly equal to 0, to see who won, or help determine who won. So we'll say positive favors the attackers, negative implies that defenders win. And you could invert that logic if you want. That's just arbitrarily what popped into my head. So now I can loop into I equals to 0, I is less than the size, and increment I each round. This is our time to go through the collections and run the battles and manage our balance. So as you can imagine, we have to be careful because one of these arrays might be shorter than the other, and we don't want to overrun the bounds of it. So to handle that, I'm going to set up these local variables. I'll call one attack strength, and I'm going to do one for the defense too. And the idea is going to be that we'll check if the index is valid for its corresponding array. If I is less than attackers.length, meaning it's within range, you can safely access that value of I, then I want to use the value from the collection. And if it's not present, I'm going to use this -1 value, because I know -1 will lose to anything that's present in the other collection. So if there's no attacker and there's a defender, I want the defender to win that battle, and it's going to have some value from 0 up, and 0 and up will automatically beat -1. So that's the idea there. If I can't access, I ran out of attackers, then just sub in -1 for the attack strength. Otherwise use the attack strength for that index. And then we do the exact same thing for the defenders, but I'm going to call it defense strength. And we got to say defenders. If that index is available, you take it from defenders collection. Otherwise use -1. Something that if an attacker is present, they will definitely beat. Good. So now we have an attack strength and a defense strength for this particular battle at index I. And so now we can handle we can update our balance, right? So I can say if attack strength, oops, I forgot is not equal to defense strength, right? If they are equal, there's nothing to update, right? The balance should not be changed if those two values are equal, and we can simply just go on to the next battle. But if there is a difference, we need to update. So we can say balance plus equals, and we can say attack strength greater than defense strength, meaning the attacker won, right? If that case is true, then add 1. If it's not true, subtract 1, right? And this works because it only happens if the values are not equal. So hopefully you remember the ternary operator here, where you give it some condition, question mark denotes the end of that condition, and then you have, if true, this, if not true, use that value. And the plus equals, of course, is the same as writing balance equals balance plus 1, or -1 if it works out in this case, -1. But yeah, that's just a nicety, syntactic sugar, if you will. Hopefully, in 7 Caillou, I think you're okay with that. So, good. As we go through these now, we're going to go through all the battles and update the balance as needed. And so we have to handle a couple cases that can result at the end. The balance may be even, right? And then we have to go to our tiebreaker case. So we could say, if the balance is equal to 0, let's do that tiebreaker. And it came down to the attack power, right? So we could say return defenders.sum, is greater than, actually greater than or equal to, because if, remember for the tiebreaker, if the attack power is tied, the defenders were said to get that victory. Attackers.sum. So I used greater than or equal to. And this sum is not defined by the array class. We know that sum comes from system link. And you can look that up. You can go to enumerable. Enumerable here, right? I told you before to just keep a tab open with enumerable methods, and you'll see there's one called sum. Right there, it just adds up everything in the collection. Really simple, really handy. But you could look at that. And I told you it says the namespace that it resides in here, so that's why I had to bring in system link. Because I didn't define sum here, did I? Good. So yeah, we handled the tiebreaker case with ties in the tiebreaker going to the defenders. That'll return true. And then otherwise, it's just simply a case of returning based on the balance. Return balance less than 0, right? Because I had set it up where negative values corresponded to defenders winning. So if balance is less than 0, return true. And if it's greater than 0, this will return false, indicating the attackers win. So I think that will do it. I'll go ahead and run this. Let's do the test first. Okay, green from the start, good. I didn't type anything wrong. It's a miracle, right? A Christmas miracle. And green for the submission. We nailed it. Good. So yeah, there's probably, you may have gone about this a different way. As usual, I'd be interested in seeing that. If you came up with something else, we'll certainly check out the other submissions to see what we can gather from that. I think I'm going to send mine off like this. Not much. Actually, you know what? We could condense this a little bit. Why not? Trim it down a little bit. I think you can handle that in the 7 Caillou series. So with these two statements here, we could simplify it even more, right? We could say something like this. Return, first check if the balance is equal to 0, right? We'll use that ternary operator again. And if it is equal to 0, that means we need to use the tiebreaker case, which was this, right? Else, return balance is less than 0. Right? It's the same thing, right? I just phrased it a different way and took it from 3 or 4 lines into 1. And I still think that's very readable, but if you like the previous way, feel free to stick with that. See, I'll trim mine down to this. They're going to make us test again, which is appropriate. Still green, still golden. Go ahead and grab those honor points. I'll fire mine off here. And that is another solution in the bag. You know what to do. Scroll through some of these, see what you can learn from other people too. Why learn from one person when you can learn from 100 people? Otherwise, hit me up in the questions and comments. I'm always happy to help. I appreciate the feedback I get, constructive or otherwise. And I will see you in another video. Thank you.